Right, another question on modelling with first order differential equations. Question number 3. The rate of change of the velocity of a raindrop is proportional to the difference of the velocity and a constant. If the initial velocity is v0, set up the differential equation and the initial condition for finding the velocity vt of a raindrop at the time t. Do not solve the equation. Okay, so we just need to set up the differential equation and write the initial condition. So in this case, the rate of change of the velocity of a raindrop, so let's assign a letter. Let me let v be the velocity of the raindrop. So let me pick up the pen. So let me let v be the velocity of the raindrop. So v is the velocity of the raindrop, and in this case it says the rate of change of velocity, so rate refers to d by d small t, so rate refers to the rate of change with respect to time. So let's start off by writing our differential equation. So dv over dt in this case, so it's the rate of change of velocity, so i.e. dv over dt, and that is proportional to, so that is proportional to the difference, so difference relates to minus, but this is the difference of the velocity, i.e. v, and a constant, so I'm going to take c to be our constant. So I'm going to say in the corner c refers to our constant. So let's get rid of this proportionality sign. So moving to the next step, dv over dt, and that is equal to, let's add a constant of proportionality. So k is our constant of proportionality. So k into v minus c. So let me just say another note, k is our proportionality constant. And we're not done yet because we wrote our differential equation. Here's our differential equation, but we also need to write down the initial condition. So let's write down the initial condition. Initial condition relates to what happens when the time small t is 0. So here's our initial condition. When t equals 0, okay, the velocity of our raindrop v, so remember v is the velocity of the raindrop, v is the initial velocity, which is v0. So this being over here our initial condition. So here we go. So we wrote down the differential equation, so we set this up and we stated the initial condition. Here's our initial condition. Do not solve the equation, so we did what is asked, and this should be the solution to question number 3. I hope you enjoyed and liked the video. If you did enjoy the video, be sure to subscribe, and I hope to see you again. Thank you.